I would really like to touch base about the important support of Department of Science, Technology and Innovation that enable us to do these activities. So speaking of hydrogen, hydrogen is an element very abundant in the universe, and it's an energy carrier. You can produce it by, as you said, splitting water, using sunlight, for example. And then hydrogen finds multiple applications in industry. It's produced currently at about 100 million tons a year. It's a commodity chemical, and it is used in methanol production, in ammonia production, in refining petrochemical products, but it also can be used as a fuel, as a clean fuel. And over the last few years, we've been working along the value chain of South African minerals, for example, and create skills that would allow us to unlock the value chain across the hydrogen technologies, across the mineral base. And one of the examples today, you will be seeing mobility using hydrogen in partnership with Toyota South Africa. This is the so-called sustainable mobility, where you can produce hydrogen in the backyard of your house, your own fuel, and it's clean, and the driving range is very similar as the petrol cars.
Now, it's not as simple as you put it. Many of us are wondering, how do you then take the hydrogen, turn it into electricity for this kind of electric vehicle?
As you said, it's not as simple, but there is a technology behind production of hydrogen, which is called electrolysis. And we use technology as referred to proton exchange membrane electrolysis. It uses iridium and platinum, core element of platinum group metals that you can mine in South Africa. And then hydrogen has to be stored somewhere, and it has to be delivered to the point of use, for example, refueling system. And there's lots of catalysis development, lots of chemistry, lots of mechanical engineering is required. And we engage all kinds of skills development, from artisans to technicians to PhD level students. As you said, it's not that simple, but hydrogen from water has been known for many years. It just didn't find the right cost structure yet, but we're working towards the cost reduction.
We assist the Department of Science, Technology and Innovation in terms of running their 4 RDI energy programs. And the HISAB program is one of the programs that we are assisting the DSTI in terms of running. So the rapid prototyping facility that we are in today, that we are opening today, is one of those that were funded partly by the DSTI grant, and also with the other partners. The ARM was also a partner to this particular facility. So today we are basically opening this rapid prototyping facility that will assist us in terms of developing prototypes that have got to do with the hydrogen economy. As many people know, the DSTI has funded this program for more than 15 years. And we are now at a level where we are starting to ramp up, bringing in the private sector to try and take some of the IP. And also we have further development of some of the IP into the commercial side of things. Today we also have the opening of the handover of the Mobile Refuelling Station, which was a partnership between Northwest University, the DSTI, SANEDI, and Toyota on the mobile refueling stations for passenger vehicles. The refueling station adheres to all standards, international standards and also the national standards. This is quite a major milestone for us as this consortium between the DSTI, SANEDI, Northwest University and Toyota, because it will assist us in terms of kickstarting the hydrogen economy on the mobility side of things. So after the handover today, the Toyota Mirai, the car that is behind me, will be moved together with the mobile refueling station to Gauteng, and then it will be used to showcase the use of hydrogen in the mobility side of things. So this, like I indicated, is a great milestone for South Africa and also for the various partners involved.
I mean, our involvement as African Rainbow Minerals is basically collaboration with the Department of Science and Technology and Northwest University, and with the government as well. You know, just that aspect of seeing what we can really do together as a collective, you know, just to make sure that we support the academia support the learners so that they can really translate the academic lessons into the practical, life-changing solutions with realities that we are facing. As you know, I mean, for us, it's just more than mining, but with this mining, it evolves. There's an issue of new technology. There are new challenges that are ahead of us in terms of the decarbonization agenda. So we're all looking for lasting, sustainable solutions. And we do believe that through this infrastructure, it will be an enabler, for the learners to dig deeper into the research and development. And as a result, basically cultivating new skills that we're going to need, especially when we talk about the hydrogen technology. As you know that we do have this supply of PGMs, which are mission critical for the hydrogen technology, the platinum and the iridium. All that we need to do is to scale up, come up with lasting solutions, come up with economically viable, solutions, so that into the future, the issue of energy security and also energy costs are actually supportive, in terms of our business value chain. But the importance of skilling, upskilling, capability building for our learners, it's also one of the objectives. Just bringing the practical aspect into the learning institutions.